first concept is finding the real nth root of a, and I just ripped this out of the textbook. It says let n be an integer where n is greater than 1, and let a be a real number. So there are two situations. N could be an even integer, or n could be an odd integer. And what you need to do is look and see what is a. If a is less than 0, then there's no real roots. If a is equal to 0, there's one real root, which is 0. And if a is greater than 0, a is the number that you're taking the root of, there are two real nth roots, plus or minus the nth root of a. That n could be any even integer. Remember, that n could be a 2, a 4, a 6, or an 8, and you get plus or minus the root of that. The other situation is if n is an odd integer. If a, the number you're taking the root of, is less than 0, there's one real nth root. If a is equal to 0, there's 0. And if a is greater than 0, there's still one real nth root. So if n is an odd integer, like 3, 5, or 7, there's only one square root. You're not going to have the plus or minus thing like we're used to seeing if n is odd. So for example, here's a situation where n is 3, and a is equal to negative 216. What this looks like is the cubed root of negative 216. Another way we can write this is negative 216 to the 1/3 power. And if you're plugging that into your calculator, you would write something like negative 216 caret 1/3. That's how you'd evaluate it. Now, looking at the table, we know n is odd, so we're going to look here. A is less than 0. We're going to have one real nth root. And to find that, if you know what it is, that's fine. Or you can plug it into your calculator. You can plug this in as negative 216 to the 1/3. And you know the answer is negative 6. Okay, I'm going to erase this and solve the second one. The second one is n equals 4, a equals 81. So n is an even integer. A is greater than 0. It's going to have two real nth roots, plus or minus the root of that. So we have 81, the fourth root of 81. Or you can write 81 to the 1/4 power. Same thing. Plug that into your calculator, see what you get. 81 to the 1/4, and the answer is going to be 3. And of course we have to write plus or minus 3 because that's what it says. Our answer, we're going to have two answers, plus or minus that number. The next thing you need to do is evaluate things like this, 16 to the 3/2 and 32 to the negative 3/5, and you have to do this in two ways, rational exponent form and radical form. Rational exponent form looks like this. You're just going to write down 16 to the 3/2. You're going to rewrite this as 16 to the 1/2 power, and if you know what we're talking about, 16 to the 1/2 power, it means the square root of 16 to the 3rd power. So from 16 to the 3/2 to 16 to the 1/2 to the 3rd power. 16 to the 1/2, if you plug that into your calculator, or you know the square root of 16 is 4, you're going to do that. 4 to the 3rd power. 4 to the 3rd power is 64. So that was rational exponent form. Let me show you how to do this in radical form as well. So 16 to the 3/2 is equal to the second root of 16. That's just the square root. We don't need to write this 2 here, but I'm going to do it anyways. To the 3rd power. The square root of 16 is 4 to the 3rd power, and that's 64. So you get the same answer in two different ways. You just need to recognize 16 to the 1/2 is the same as the second root of 16. Let's look at that second example. It says 32 to the negative 3/5. And first we're going to rewrite this. You probably already realize it has a negative exponent, so we can rewrite this as 1 over 32 to the 3/5. So that's what you do when you see a negative exponent, like you already know. We're going to rewrite this as 1 over 32 to the 1/5 to the 3rd power. Because that 5's on the bottom, we write 32 to the 1/5. Bring this 3 outside to the 3rd power. 32 to the 1/5, you can plug that into your calculator. And when you do that, you'll get the answer is 2. Leave that 3rd power. 2 to the 3rd power is 8. So our answer is 1 over 8. Okay. And if we're going to do this in radical form, once again, same type of question. We're going to start the exact same way. We're going to put 1 over 32 to the 3/5. The first step's, of course, to move to the bottom. We're going to rewrite this as 1 over the 5th root of 32 to the 3rd power. The 5th root of 32 is 2, so 1 over 2 to the 3rd power, and you get 1 over 8 again. Alright, switching back and forth is a very useful skill. I just showed you how to do it from rational exponent form to radical form, but you just need to know how to switch back and forth. So let's do a couple more examples. So 16, let's say, to the 2/5 power is the same as the 5th root of 16 squared. You can switch back and forth like this. One more example. Let's say you have the 8th root of 2 to the 7th power. Well, you'll flip that to 2 to the 7/8. The root is the same as the denominator, always. The root is the same as the denominator, and the exponent is the same as the numerator, so 7 and 7. I just wanted to add a little note here on the end of the video, and specifically how to simplify a radical without the calculator. So let's say you have like the cube root of 54. This is simplified in the exact same way a square root is, except now you just need 3 instances of a prime number in order to remove it from the radical. So for example, 54 is 2 times 27, 27 is 9 times 3, and then that's 3 times 3. So the 3 shows up 3 times. That matches the number outside, which means you get to bring it outside the radical once, and you have 3 times the cube root of 2. This is the same for something that's even larger. Like let's say you have like the 7th root of some number, yeah. A prime number would have to show up 7 times just to remove one instance of it from the radical.